we'll do this. These two questions are a review of what we started talking about yesterday. Remember, I said the topic is conic sections. Basically, the topic is what the shapes, the type of graphs we get when we graph different types of quadratic equations. So, and we mentioned the four types were the circle, ellipse, hyperbola, and parabola. And we're going to look at the equations. We should, by the end of this discussion, which will not finish, probably will finish on Tuesday, it will take us till Tuesday to do all this, that it, by that point, we should be able to look at a quadratic equation that has x's and y's, and we'll know it's quadratic because it'll have an x squared and a y squared, or maybe just one, but it'll have an exponent of 2 either on the x or on the y or on both. And we'll be able to tell what kind of shape we're going to get. Now, we mentioned the first type that we talked about was the circle. The basic equation for a circle is x minus a squared plus y minus b squared equals r squared, where the point A, comma, B is the center of the circle and the R is the radius. Think about it. If you wanted to draw a circle, the two important things you'd need to know is where is the center of the circle, where's the middle of the circle, and then how big is the radius? Because once you have both of those pieces of information, you could definitely draw your circle. Now, in this case, they told me that the center of the circle was -2, 5. So the A in this case is -2. The B is 5. And the R, they told me, is the radius is 7. So the R is 7. So if I were going to write this equation, it would be x. Now I don't write x minus 2. It's minus 2. So it becomes x plus 2 squared plus y minus 5 squared equals 7 squared, which is 49. And you don't have to remove the parentheses. You could leave your answer just like this. This would be your equation of your circle. Again, notice how the numbers inside the parentheses are switched signs. This was a -2, so in the parentheses, it's a +2. This was a +5, so in the parentheses, it's -5 because it's x minus a. So, and if I notice, let me see on the chat, Cheryl wrote x plus 2 squared plus y minus 4 squared equals 49. Perfect. That was perfect, Cheryl. Good. Okay, so now I want to go to the next question, and I'm probably going to need more room than what I have over here. So I'm going to erase this. Does anybody still want this on the board?
Yes.
Okay, I'm giving you a couple of minutes, and I'm not going to take, let me just mention while you're, that if you look after class at Delta Math, you will see that quiz number 4 has been posted. And I'm giving you until next Friday to complete it. Again, I think I gave you, it's 10 questions. I think I gave an hour. If you, and like all of them, if you find it's not enough time, just email me, I'll extend the time. If there's any reason that it's not, you can't work it out that way, if the timing is not good, these are tests that I'm giving. I want to see the point of these quizzes and the tests that I give is to see that you're doing the work, you're current, that's what the homework is all about. Remember, 40% of your final grade is from what happens in class or in homework or in discussion. So you want to get as many of those 40 points as you possibly can. Most people did do very nicely on the, okay, thanks, April, I'm going to do that. Most people did very nicely on the midterm. And, but remember, the final is 35% of your grade. And if you're behind on the work, we have 3 weeks of class left. Get it done. Anything, any homework, it doesn't matter what mark you get on it. As long as, and I'll tell you probably a week before how many homeworks you have to do in order to get the full 10 points for the homework. You don't have to, probably by that time, there'll be 23 or 24 different homeworks. At this point, I think we're up to number 18 or 19, so there might be, no, there'll probably be about 20. I won't necessarily say you have to do all 20, but I'll probably cap it at something like 16. If you did 16 homeworks and you didn't have to get 100 on all of them, then you'll get the full 10 points for the homework. So make sure if you're really behind on those homeworks on Delta Math to get them done. If you need it to be extended or you need it opened up, you started it and it closed on you, whatever, just let me know. I'll gladly take care of that. Okay, so the second question that I gave you was to find the center and radius of this circle x squared plus y squared minus 6y equals 7. Now, actually, as soon as I see an x squared plus a y squared, I know that this is going to be a circle. So how do we take this x squared plus y squared minus 6y equals 7 and make it into standard form for a circle so that we can figure out what its center and its radius is. So if you recall, what we said is we're going to do the process of completing the square so we get a binomial squared for both the x and the y. Now, actually, the x squared is standing alone. There's no other x term, so I really don't have to do anything with the x. I can leave the x squared alone. But when it comes to the y, since there's a y squared and then there's a y term itself, if you recall, what we do is we divide that number by 2, which gives me -3. And I multiply that number by itself. I square that number. So -3 times -3 becomes +9. I have to add 9 to the y squared minus 6y to make that a perfect square. Since I added 9 over here, I'm going to have to add 9 on the other side to maintain my balance. So that this y squared minus 6y plus 9 can be written as y minus 3 squared. We made this into a perfect square binomial. Again, remember the steps. Half the number, if this was x's there, then it would be half the number in front of the x. Now this is the y, half the number in front of the y, that's -3, multiplied by itself. On the other side, we now have 7 plus 9, which equals 16. So actually now I have this equation that started out looking like this without any of the parentheses in what we call standard form. So now we should be able to write what the center is and what the radius is. Now the center is usually, we have the X in a parentheses with something also. But since there's really nothing there, it obviously means that that number there must be a 0. In, in the parentheses with the Y, we have a -3, so that number has to be 3. The center of the circle is 0, 3. The radius is the square root of 16, so that means it's 4.
They always get the bank now before they want to do me bank.
So we now have all the information we needed to find the center and the radius. The center is 0, 3. The radius is 4. Again, remember, if there's if there's no extra terms with the x's, then the center for the x will be 0. If there's no extra terms with the y, then the center for the y will be 0. Yes, you have a question, Jennifer.
So once we get the answer where it for the radius, before we you see how it says x squared plus y minus 3 squared equals 16. So
Right.
once we find that number at the end, it's always going to be the square root of that, the
Right.
radius.
This is always the radius squared, so you have to take its square root.
Okay.
And it's always going to have to be a positive number. It can't be a negative number. If it's a negative number, then there's no circle. Can't be.
Okay, thank you.
Okay, so that answered your question, Ashley, as well. So again,
Professor,
yes.
how about the center? It says y minus 3. So do we put the opposite, which is positive 3?
Always put the opposite sign. This is -3, so this becomes +3. If this would have been a +3, then this would have been the minus. The center and the number inside are the same number, but opposite signs. They always have the opposite sign.
Okay.
Are we okay with this now?
Yeah.
Anybody, any questions before I go further? Because this really takes care of the circles. And I wanted to go on to the next topic, which is the ellipse. Okay, any questions? Everybody understand the circle, the whole business, how to put it in standard form, how to read the center from the numbers in the parentheses. Again, since the x had no, it was like having x plus 0 in a parentheses. So it doesn't affect it. Okay, so I'm now going to go on to the next topic, which is called the ellipse. So this is the second of our 4 conic sections. It's an ellipse. It's a oval shape, in other words, a flattened out circle. And it could be flattened out horizontally, or it could be flattened out vertically. It doesn't, it's different either way. So the question is, what do we have to know about an ellipse? So the basic equation of an ellipse looks like this. X squared over a squared plus y squared over b squared equals 1. This is what's called the standard equation of an ellipse. The only types of ellipses we're going to do are going to be ellipses that are centered at the origin. The center of the ellipse. Now remember, we started out talking about circles. that were centered at the origin, but then we went on to doing circles that had centers other places. With the ellipse, we only are going to talk about those that are centered at the origin. As I said, this is the standard format. Notice it's going to be x squared over a squared plus y squared over b squared equals 1. It always has to equal 1 on this side. And obviously the a and the b have very strong significance. Let's do an example. Suppose I gave you that x squared over 25 plus y squared over 16 equals 1. Now notice that is in this setup. It's x squared over a number plus y squared over a number equals 1. It's in the standard format. If you notice, the a squared in this case obviously is 25. And the b squared, the number that's under the y squared, is 16. So the number underneath the x squared is what we call the a squared. The number that's under the y squared is called the b squared. What do these numbers tell you? Well, obviously, if a squared equals 25, the a is either positive or negative 5. The a is the x-intercept. It's where the graph is going to cross the x-axis. It'll cross, if the a squared is 25, it'll cross at either positive 5 or negative 5. The b squared, if the b squared is 16, that means the b has to either be positive or negative 4. The b is the y-intercepts. It's telling us where the graph is going to be crossing the y-axis. So if I went to draw this graph, here's what it would look like. Here's my x, here's my y. We said the a is 5, the x-intercepts are 5. So I go 1, 2, 3, 4, 5. Positive, negative 1, negative 2, negative 3, negative 4, negative 5. These 2 points are where the ellipse is going to cross the x-axis. We said the y-intercepts are 4 and negative 4. So I go up 1, 2, 3, 4. And then I go down 4. 2. The y-intercepts are 4 and negative 4. Now, really, I don't need any further points because I can just connect these points. Obviously, I don't do it with straight lines. I do it with curvy lines. And if you notice, what we get is it looks circular, but it's been flattened out a bit. It is an ellipse. So what do we need to know about our ellipse? Again, there are much more complicated ellipses. There are ellipses that have centers other than at the origin. You are not required to know those. So you only have to have the ellipse that has a center at the origin and the number underneath the x squared. If you take its square root, you have to take its square root, will tell you where it's crossing the x-axis. And the number underneath the y squared, when you take its square root, will tell you where it's crossing the y-axis. And when you have those 4 points, you'll be able to graph the ellipse. It turns out that the line that cross through, notice there are 2 lines that cross straight through this ellipse. There's a horizontal line that is, if you fold it in half along the x-axis, one half of the ellipse will go right on top of the other. That line is called the, these are axes. This is, one axis is horizontal, one axis is vertical. Now, if you notice, the two axes are not the same size. That's what makes it an ellipse rather than a circle. In a circle, all four of these numbers would have had to be the same. If this was 5, this would have been 5, this would have been, they'd all have to be 5. When they're different numbers, when the x-intercepts and the y-intercepts are not the same, then what you get is an ellipse. The longer axis, which in this case is the horizontal line, is called the major axis. If you were to ask me how long is the major axis, well, it's going from -5 to 5. So if you count it, it's going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The length of the major axis is 10 because it's going 5 to the right and 5 to the left. The other axis, the smaller one, is called the minor axis. The length of the minor axis in this case is, it's going from -4 to 4, a total of 8. So we have these two lines that are important to talk about. The major, notice if I had this type of an ellipse, the major axis would have been along the x-axis and the minor axis would have been along the x-axis. The major axis stands for the longer one, the minor is the smaller one. In this case, they are very close in size. That's why our thing is closer to a circle.
Okay, Professor, I'm sorry.
Yeah,
Can you go over again the major axis and the minor axis?
right. Let me do it, give you a different example. Let's say this was -6, and this was 6, and this is -2, and this is 2, right? You could have something like that, let's say. Obviously, the major axis would be going this way because that's the longer one. This is the minor axis. Now, the major axis, if you're seeing it's going, if you're starting at the origin, at the 0, you're going 6 to the right and also 6 to the left. So the total length of that major axis would be, I'm going to call it major. I'm not going to write axis. Would have to be 12 because it's going from -6 to 6, or just double because it's going, we're not asking how much is it from the center, but we're asking how much is it from one point to the other point. The minor axis is, well, we're going from -2 to 2. That's the shorter one. Obviously, from 0 to 2 is 2, but from -2 to 2, it's 4. So the length of the, in that case, for this example, the major axis would be equal to 12, and the minor axis would be equal to 4.
Okay, I understand it now, because when you look at the one that you did on the right-hand side, on my side, it looks like an 18. So I was trying to figure out where did you get an 18 from? But then I figured out that it was a 10.
Part of the Y, the J, sorry.
But now I figured out that it's a 10, so now I get it. All right, thank you.
While we're at this, actually, if I look at this example that I just was talking about over here, where the major axis was 12 and the minor axis was 4, I could actually write the equation, because we should be able to do this both ways. We should be able to look at the equation and be able to tell what the graph looks like. And we should also be able to take what a graph looks like and write its equation. Well, if I look at it, if I look at this one, I see that the A has to equal 6 because the A is how far it is from the origin to the place where it crosses the x-axis. So even though the whole major axis goes from -6 to 6, the x-intercept is 6, which means the A is 6, which means the A squared would be 6 times 6, or 36. The B is the y-intercept. Now, it could be, usually go to the positive one. That means from how far is it from the origin to where it crosses the y-axis. And the B we see is 2, which means that the B squared would be 2 squared, or 4. So for this particular ellipse, the equation would be x squared over 36 plus y squared over 4 equals 1. So here we went from the one we did before, we went from the equation, I gave you the equation of the ellipse, and then we went to what it looked like. Here I gave you the picture of the ellipse, and we went to the equation. Now, what makes the equation different than an equation of a circle is these numbers, these A's and these B's. If the A squared and the B squared have to be different numbers. It's going to be x squared over A squared plus y squared over B squared. A and B cannot be the same number. If they're both the same number, if this was the same number as this, then what we'd have is a circle and not an ellipse. So the big thing that makes an ellipse equation different than the equation of a circle is the fact that we have these two different numbers, A squared and B squared. Okay, let me look at the chat and see what the questions are. Okay. Is anybody having trouble seeing me? Anybody having problems? Okay.
No, Professor, I'm good. I went out and came back in. It was good.
Okay.
Thank you.
Okay, thanks a lot, Devonna, for telling me that you're okay. Okay, so I'm going to erase some of this because it's getting rather messy, and I'm going to continue with what I wanted to say about the ellipse. Now, I specifically told you about what the ellipse equation looks like in standard form, but not always is it in standard form. And we're going to have to recognize an equation of an ellipse, even if it's not in standard form, so that we can put it in standard form. So, for example, what if I gave you an equation that looks like this? 16x squared plus 25y squared equals 400. Now I look at this equation and I see an x squared and a y squared. Now there are really going to be three types of graphs that have both x squareds and y squareds in it. One is the circle, one is the ellipse, And one is this third thing that we're going to call a hyperbola that we're not going to talk about right yet. Might get to it a little later. So we have, how do I recognize that this is an ellipse? And how do I put it in standard form? If you recall, one of the first things I did was a regular circle, x squared plus y squared. I think it was 16. I think that was the first type of graph that we looked at. And I said, when you hit just a plain x squared and a plain y squared, nothing in front of the x squared and y squared. In other words, the x squared and the y squared have the same coefficient of 1, then this was a circle. Here we have an x squared and a y squared as well. But the numbers in front of the x squared and the y squared are different numbers. The coefficient of the x squared and the coefficient of the y squared are different. That's what makes it an ellipse. If the coefficients of the x squared and the y squared are the same, usually they're just 1, it's a circle. If the coefficients of the x squared and the y squared are different, it's an ellipse. That's what makes it an ellipse. But it's not, so if you remember, we said this was a circle and the radius of the circle was 4. But let's go back to this ellipse. How do I draw this ellipse? How do I get this ellipse so I know where it's crossing the x-axis and where it's crossing the y-axis? So in order to do that, I want to put it in standard format. Just like with a circle, I needed my circle in standard format so I could see what the center was and what the radius is. When we have an ellipse, we also have to put it in standard format. So how do we go about this? I look at the number that's on the other side of the equation, the standalone number. Now in standard format for an ellipse, that has to be equal to 1. So whatever this number is, I have to divide by it. I have to divide by 400. But if I divide the right side by 400, I have to divide the left side by 400 as well. In other words, I have to divide every single term of this equation by the number that's over here so that it ends up being 1. I have to do the same thing to everything so that I maintain my equality. And then I have to reduce. Well, I'm going to use have my calculator help me. I think the top and bottom here can be divided by 16. So let's see what 400 divided by 16 will give me. Oh, it gives me 25. So I can reduce this to 1 over 25. Now what about the 400 divided by the 25? That gives me 16. So I can cancel this out and this will give me 16. And obviously this both cancels out, so I'm left with 1. So that this equation becomes x squared over 25 plus y squared over 16 equals 1. I didn't even realize it. It actually came out, I think, to the exact equation that we had before. This was not in standard form. Until I have it in standard form, I can't tell you where the x and the y intercepts are. But now I can say, I know the a squared is 25. So the y intercepts are plus and minus 5. And again, the b squared is 16. So the b is plus or minus 4. And just as we had before, we go to 5 and negative 5 on the x-axis, because that's the a. We go to 4 and negative 4 on the y-axis, because that's the b. and then just connect it, and we would have our ellipse. So, and basically, that's all you really need to know about an ellipse. Okay, so I'm going to give you an example. Suppose I give you this example. 2x squared plus 8y squared equals 32. I'm telling you it's an ellipse, but you would know it anyhow because it has an x squared term, a y squared term, and the numbers in front of the x squared and the y squared are different numbers. This is definitely an ellipse. Here's what I want you to do. I want you to put in standard form. I want you to figure out what the x and y intercepts are, and then I want you to sketch it. While you are doing that, I'm going to take attendance. So again, you're going to sketch it. You're going to put it in standard form, find the A's and the B's, and then sketch it. Is there any reason why so few people are here today? I don't think I ever had such poor attendance.
I couldn't connect yesterday,
What?
but I couldn't connect yesterday.
You couldn't connect yesterday?
Yesterday, I think it was on my end though.
Because yesterday I attend, and I have you, are you sure you weren't here? Because I have you marked present.
I got like kicked off at like 11:10. So I have to watch the last 30 of class.
Okay, I hope that this is not running into the, oh, okay, Luke, I'm glad you're here. You just came in, okay. All right, I'm gonna take attendance now. Azia,
Yes, Professor, good morning.
good morning, good to hear from you. Nashia,
Here, good morning.
good morning. Annabelkis, Emma,
Hi.
hi, I know you're here. Messiah, are you here? Corey,
I'm here.
oh, good. April,
Good morning.
I worry when it's my standards that don't show up. Some of you have, I think, almost 100% attendance. This class is a great class. This is the third term I'm teaching online, and this is the best class I had. Khadija. Umar. Yakima. Cheryl, I know Cheryl is my standard for coming early. Stacia.
I'm here, Professor.
Denisha. Devana, I saw you were here.
Yes, I'm here. Good morning.
Yeah. Natalie.
Morning.
Good morning, Natalie. Erica.
Good morning, Professor.
Good morning. Jonathan, you said was out. Okay. Luke, he said he just came on, so I see he's here. Layla. Layla, are you here?
Yes, I'm here, Professor.
Okay, I got your email and I'll take care, you did send me an email, right?
Yes, I did send
Take
it.
care of it after class. I just got it.
Thank you.
Ashley, I know you're here. Kachira. Kachira. Jennifer, I know you're here.
I'm here.
Oh, Kachira, good. I thought you were here. Okay.
Professor, you said us we're supposed to find the eclipse, right? Sorry. We're supposed to find what are we supposed to graph?
Okay, you're supposed, this example here, put it in standard form. Figure out where it's crossing the X and Y axis, in other words, the intercepts, and then sketch it. Just do a sketch on your paper. It doesn't have to be too exact. Rachel here? And Gloria. Here.
Professor, I have a question. This is Erica.
Yeah, hi, Erica.
Hi. Did you, I know I have to send you an email, but I'm trying to just ask you word of mouth. Did you do the extension for me? Or I still have to email you?
If you
Do you
didn't,
pick up?
unfortunately, my memory, as soon as I walk away from here, I forget. If I'm sitting at the computer and I'm looking at it, I remember, but I don't remember who said to do, just send me an email.
Oh, okay.
And
For the quiz, I was just wondering because I still can't get into it, so I might have to wait till after class. But I don't know if you put in the extension.
I probably did not. If you didn't send me an email, I probably did not. What I do is at the end of class, I try to take care of all my bookkeeping, like.
You usually remember those.
Well, I remember that my students, but I don't always remember who asked me what.
You would have to restart it or don't take it yet or what?
Did you take it at all?
No, today's quiz I'm talking about. Because I didn't email you for the extension.
Wait, which quiz are you talking about? 3 or 4?
The quiz after, you said after class.
Oh, and then it shouldn't have been available to you yet.
Okay, that's what I was concerned if I had the extension. Because I didn't tell you.
You're supposed to get extra time.
Yeah.
Send me an email because I'll forget.
So don't take it, right? Just send you the email first.
Right, but well, if you start taking it and you run out of time, I can always give you an explanation afterwards. I can do it either way. It's Delta math is easy for me to make changes.
Okay.
So
thank you.
Whichever way you do it, it's gonna work.
Okay, thanks.
As long as you let me know.
Okay.
Okay.
Thank you.
You're welcome. Okay, so let's look at this now. And see if we can, I see a bunch of people have already done it. Okay. So here's the equation that they gave me. 2x squared plus 8y squared equals 32. As I said, I recognized it, even though they probably tell you, if I look at an equation, it'll probably say graph the ellipse or graph the equation. It probably will even tell you it's an ellipse in the question, but I wouldn't need to be told it's an ellipse. How do I recognize it's an ellipse? I have an x squared and a y squared term. I see it's a quadratic. with both the exponent of 2 on the x and the y. And since the coefficients of the x squared and the y squared are different numbers, that makes it an ellipse. And in order to put it into the standard format for an ellipse, what we have to do is get it equal to 1. So whatever number is over here, I divide it by that number. So I'm dividing everything by 32. Whatever decisions I'm making about an ellipse, I have to first have that ellipse in standard format. If it's not in standard format, put it in standard format, then I can make decisions. Well, over here, I have a 2 on top and a 32 on the bottom, so I can reduce this. The 2 goes into the 32, 16. So that'll give me x squared over 16. Here I have an 8 on top and a 32 on the bottom, so I can cancel it out and get a 4 on the bottom. So that'll give me y squared equaling 4. And the 32 divided by 32 is now 1. It's now in standard format because it's x squared over something plus y squared over something equaling 1. All right, now I can tell you what my x and y intercepts are. The a squared is always the number that's underneath the x squared. Even if I had the y squared first and the x squared second, if they put it in the wrong order, it wouldn't matter. The a squared is the number that's underneath the x squared. It happens to be 16, which means the a, which are the x intercepts, are either plus or minus 4. So one x-intercept is 4, and the other one is -4. Remember, I'm using this special symbol, plus over minus, because it's easy to write. It's quick. It means 2 answers, +4 and -4. The b squared is the number that's underneath the y squared. That happens to be 4. So the b has to be the square root of that plus or minus 2. So when I go to graph this, here's what I'm going to get. I'm going to go to 4 and -4 on the x-axis because my x-intercepts are 4 and -4. On the y-axis, I'm going to go up to 2 and down to -2. And therefore, I'll get an ellipse that looks like this. Looks like a football, pretty much. Notice, if I ask you how long is the major axis, you would say the major axis is along the x-axis and it's 8 units long. And the minor axis is the one along the y-axis is 4 units long. It's always double these numbers. How many, let me see, I see a bunch of answers in the chats. Good, most people got it right, great. Let me give you one more to try. Suppose I tell you that I have a, can I erase this? Okay, yes, I can. Here's my other question. I have an ellipse whose major axis is 10 units, and it's along the y-axis. The minor axis is a total of 6, and it's along the x-axis. I'd like you to write me the equation of this ellipse. Write the equation of this ellipse. Okay, let's see if we can do this. I'm going to draw a sketch of this so I have an idea of what I'm looking at, and then I'll be able to write the equation. So here's my x and y axes. We're told that the major axis of this ellipse is along the y-axis, and it's a total of 10, which means if it's a total of 10, it has to go from the middle to the tip. It has to be 5, and to the bottom it has to go to -5, because the total thing has to be 10. The minor axis we said was 6, and it's along the x-axis, which means it has to go 3 to the right and 3 to the left. In other words, if I were saying what my actual, it didn't ask this, but if it asked me what my intercepts are, my x-intercepts are 3, 0, and -3, 0. Remember, in an x-intercept, the y of the point is 0, and the y-intercept is 0, 5, and 0, -5. They didn't ask me to do this, but if I could, it's easy enough for me to figure this out. Okay. In other words, this is what my ellipse would look like. This is a little bit different than the others because my major axis is vertical and my minor axis is the horizontal. But now we can easily say, remember our standard equation, we're going to put our equation in standard form. A in this case is either the 3 or the -3, because it's the x-intercept, which means the a squared has to equal 9. The b is the 5 or the -5. It doesn't matter which you consider it, because then the b squared is 25. So now I have all the information I need. X squared over 9 plus y squared over 25 equals 1. So we could write this equation. Now, if they would not give you your equation, let's say this was a multiple choice question, and they gave you answers that were not in standard form, you would have to put your answers in standard form to compare it to the answer that you got. Be very careful that we're getting answers in standard form. And basically, this is all you need to know about an ellipse. You should be able to look at an equation. If it's not in standard form, put it in standard form by dividing by the number that's on the other side of the equal sign. If it's not 1, you've got to get it equal to 1. So divide everything by that number. And then the a squared is the number that's underneath the x squared. The b squared is the number under the y squared, and they give you the x and the y intercepts. So you can find what the graph looks like. So you can find the x and y intercepts. You can tell what the major and the minor axes are. Or as we could have done backwards, we could have started with what the graph looks like and come to the equation. And we put the equation in standard form. Does anybody have any questions about the ellipse? Okay, so I'm going to go on to the third type of conic section. Again, remember, conic sections are circle, ellipse, hyperbola, parabola. We're now going to be talking about the hyperbola. When you look at the equation of a hyperbola, you're going to look at it and you're going to say, oh, it looks just like the equation for an ellipse. It's almost identical. There's one major change. The standard equation of a hyperbola is x squared over a squared minus y squared over b squared equals 1. Or it might be, in other words, you have a minus in between them. It might be that you have y squared over b squared minus x squared over a squared equals 1. In other words, in this case, you have, again, an x squared term and a y squared term, but the sign in between them is minus. For both the circle and the ellipse, the sign in between was plus. That's why they looked so similar, because it was just a matter of squeezing a circle and you got an ellipse. A hyperbola has a very different look, because this minus makes a very big difference. But if you look at the equation, if you're not careful, you're not going to see the difference. You have to focus on the fact that you have both an x squared and a y squared, but the sign in between them are minus. It turns out that the a squared and the ab squared, in an ellipse, they must be different. But in a hyperbola, they could be the same number or they could be different numbers. Doesn't matter. The big thing with a hyperbola is the fact that you have a minus in between them. So let's see how this affects the look of the graph. I'm going to give you an example. Suppose I gave you x squared over 16 minus y squared over 25 equals 1. If you think about this, this is really as if this was a plus. If I put this into a plus and made this a minus, it would show you what the problem is. The a squared in this case is 16, but the b squared is not 25 because there is this minus over here. That minus is part, you can think of it as part of the b squared. The b squared is negative 25. Even though we put it, remember when there's a minus in front of a fraction, it could either be on the top or on the bottom. If we take this minus and put it in the bottom, we'll see that we're getting b squared equals negative 25, which means when we graph, we can only use real numbers, and the b squared being negative 25 would mean the b would be 5i. It wouldn't be real. So the b squared has no solution. And all we have is the a, which is plus or minus 4. The fact that there's a minus in between them means that there isn't both an x and a y intercept. There can only be x-intercepts when the x squared is positive and no y-intercept. But if it would have been y squared minus x squared, then we would have had y-intercepts and no x-intercepts. So what does that mean? This graph is going to look essentially like this. There's a lot more to talk about on hyperbolas, but we're really not required to do it. So I'm just going to do the very basics that you have to know. Only the positive one, if it's the x squared that's positive, you're going to have x-intercept. I'm going to do in a minute, I'm going to do one where the y squared is the positive. You totally ignore the b squared. You have x-intercepts of 4 and negative 4. And the graph, it's crossing the x-axis. It's never crossing the y-axis. It turns out that what you get are these two U-shapes back to back through the 4 and the negative 4. Notice this is the first thing we're noticing about this is that this hyperbola has two separate sections that don't connect, unless you think maybe they come around and at infinity they connect. I mean, I've heard that kind of reasoning, but really this just keeps going out wider and wider. It's not like a U that goes, the sides go straight. It keeps going out wider and wider. The two pieces are identical in terms of if you would fold along the y-axis, one half of the graph will go right on top of the other. But what you get are these two separate pieces, and the graph, the hyperbola, consists of both. It's not just one, it's both. That's what makes it a hyperbola. Again, what do you need to know about a hyperbola? You need to be able to put it in standard form. you have to be able to decide, are you going to have an x-intercepts or y-intercepts? When you have a hyperbola, you do not have both. You either have x-intercepts or you have y-intercepts, not both. And then you have to be able to find those intercepts. So if I were to give you something that looks like this, say I gave you this equation. Suppose I gave you, let me go over here. I gave you this equation, y squared over 49 minus x squared over 64 equals 1. And I look at this equation, they didn't even tell me what it is, but I know right away that it has to be a hyperbola because I see an x squared and a y squared term, but in between the terms, connecting them is not a plus, it's a minus. That makes it a hyperbola. And because the positive one is the y squared, we're going to get y-intercepts. We're going to have b squared equals 49. Remember, the a squared is really a negative 64. We cannot use the a in this case because the x squared term is negative. So the b is 49, which means the b is plus or minus 7, which means if I went to graph this, I would have to go up to 7, 1, 2, 3, 4, 5, 6, 7 on the y-axis and down to negative 7. Here are my two y-intercepts. Again, it's not crossing the x-axis, and I get these two backwards facing u's. And that's what my graph would look like, two backwards facing u's crossing at 7 and negative 7. And if they give you a picture, they'll give you, you know, I don't know if you can see the picture, but the pictures they're giving you is two of them have crossing the x-axis, two of them are crossing the y-axis. Always the positive one, the one that has the plus sign in front or has no sign in front of it, which means it's positive, that's the one you're going to have the intercepts for. For the other one, the one that's after the minus, no intercepts. Because it really is an imaginary number. Okay, I'm going to give you one to try. I'm giving you this equation, 12x squared minus 3y squared equals 48. I know it's a hyperbola because I see an x squared and a y squared term, but in between the two x squared and the y squared, there's a minus. I want you to put this into standard form. It's the same way you did it for the ellipse, and then see if you could do a sketch of this graph. I want to know what are the intercepts and what does the graph look like. I'm going to give you a couple of minutes. All right, I think we have enough time. I think you can realize that to put this in standard form means just like with the ellipse, you have to get a 1 on this side. So I'm gonna have to divide everything by 48. Because I want to get 1 over here. So this is gonna become, I'm gonna divide this by 48, and I'm gonna divide this by 48. And 12 into 48 gives me 4. So this becomes x squared over 4. And the 3 into the 48 gives me 16. So this becomes y squared over 16. And the 48 over 48 gives me my 1. So I have transferred this hyperbola, which I know it's a hyperbola because of the minus, from the format they gave me into what we call the standard format. And now I can do a sketch. I know that my a squared is 4, which means my a will be either plus or minus 2. The b squared I'm not concerned about because the b squared, the y squared is the negative, so that one is not going to have any y-intercept. It will only have an x-intercept. So my graph, the sketch will look like this. I'll go 2 to the right on the x-axis and 2 to the left on the x-axis. And I make these 2 backwards U shape. Now, actually, there are ways of figuring out if the U is a fatter U or a skinnier U. Again, that's beyond the scope of this course. But there is a lot more that you could figure out about these hyperbolas. But we really only want to be able to recognize that we have a hyperbola and be able to tell where it's either crossing the x-axis or the y-axis. Yes, Jennifer.
Okay, so in the hyperbola, we're only doing the x-axis for that's what we're finding out, only in that.
Okay, notice on that one.
But this one has the b-axis. That's
Right.
what I'm saying.
And can you tell when it crosses the y and when it crosses the x? The one that it starts with, the positive one, is the one that you're going to have an intercept for. Here, it started with the x squared being positive and the y squared being negative, so it only had crossed the x-axis. There, the y squared was the positive and the x squared was a negative, so it only crosses the y-axis.
Okay, so when the y is in front, we do the b-axis, and when the x is in front, we do the a-axis.
Right.
So, but this will only, when this in hyperbola, we only find one of each. It's not both like the other ones.
The hyperbola only has either it crossing the x-axis or crossing the y-axis. It doesn't do both.
Okay, thank you.
All right. And as I said, it's a complicated looking thing, but really for what you need to know, you need to be able to recognize that what you have is a hyperbola, and you need to be able to pick out because it's going to be a multiple choice question, you need to be able to pick out the right picture. And always remember the one that's in front, the one that's positive, not the one that's negative. Usually, if they wrote negative y x squared and plus y squared, again, look for the positive one. The one that's positive is the one that's going to have the intercepts. The other one will not. Okay. So what I'm going to do now, because we still have about 20 minutes to class, is start talking about the last type of conic section. And that's something called a parabola. And what makes a parabola different than the other three conic sections is that it doesn't have two squares. It only has one square. It either has an exponent of 2 on the x or on the y. It doesn't, notice in the circle, in the ellipse, and in the hyperbola, we have both an x squared and a y squared. Okay, Ashley. But with the parabola, we only either have an x squared and no y squared, or a y squared and no x squared. Now, most commonly, the equation will look something like this. Y equals x squared minus 10x plus 9. If you look at it, instead, it looks like a quadratic equation, except instead of a 0 equaling to 0, it equals a y. Now, the shape of, I'm not going to go totally into this, I'm just going to introduce what it's going to look like. The shape of a parabola is U-shaped. Sometimes it's a U facing up, sometimes it's a U facing down. In other words, in this case, the U has what we call a minimum point, a lowest point. In this case, the parabola has a maximum point. Now, you could have parabolas that are sideways. They could either open to the right or to the left. Again, that's beyond the scope of this course. But if you were doing more studying on parabolas, you would see if instead of it saying y equal x squared minus 10x plus 9, for example, if it started out with an x equaling a y squared, then you would get a parabola, a u that's laying on its side. Again, we're going to only talk about what we call these vertical parabolas. There's ones that either open up or open down. And I'm going to talk about just two things, and then I'm going to leave it and leave the rest for Tuesday. This point is sometimes called the turning point, because if you notice, if somebody was using this was a path, and somebody was walking along this path, they'd be going down, 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 until they got to this point, and then they'd be turning around. Or in this case, if somebody would be climbing higher, 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 and at this point would be turning around. So it's very often called the turning point of the vertex. It's one of the major features of a parabola. I'm sorry, I said vertex. It's one of the major features. The turning point is one of the major features of the parabola. It's this U shape, which means it's turning around. It's not a straight line. It comes down to a certain point and goes up, or it goes up and then it comes down. It turns around. Sometimes that turning point is also, the name used for that is a vertex. So you can either use the term vertex, or you can call it the turning point. And I would venture to say that if you had to find one point on your parabola, the most important point, it'll be the vertex. And that's one of the things we're going to learn how to do. How do we find this vertex? How do we find where it turns around? We're also going to talk about the X and Y intercepts because we did that for all of the graphs. So we're going to talk about that as well. But one of the things we're going to notice is that the number in front of the X squared, remember this looks like AX squared plus BX plus C, the coefficient of the X squared, the A will right away tell us something very important. If the A is positive, it'll be an opening up parabola. If the A is negative, it'll be a opening down parabola. So that's going to be very important because if I know what my vertex is, and I also know whether it opens up or down, I really have a very good idea of what this parabola is going to look like. And think about it. Positive, when somebody's positive, they're smiling. This looks like a smile. Negative, when somebody's in a negative mood, they're frowning, they're down. So it opens down and it looks like a frown. So those are the two things that I wanted to mention. What we're going to learn specifically next time is how to find the vertex and how to find the intercepts and how to sketch this parabola. But right now, we should be able to look at any quadratic equations with X's and Y's and know if we have a circle, an ellipse, a hyperbola, or a parabola, because they all have squares in them, but the circle has just plain X squared and Y squared with no coefficients, just coefficients of 1. The ellipse has X squared and Y squared with different numbers in front of them. Both of them are positive, both in the circle and the ellipse. The X squared and the Y squared are both positive. In the hyperbola, we have an X squared and a Y squared, but one is positive and one is negative. That makes it a hyperbola. And if we have just an X squared and no Y squared in our equation, or vice versa, we have a Y squared and no X squared, then what we have is a parabola. So we'll be able to look at a quadratic equation and tell what kind of shape it is. It's not like a circle, a line that we can put in the Y equals MX plus B form. It's much more complicated. There are 4 different kinds of shapes. And we're working on shape number 4. Okay, does anybody have any questions they wanted to ask me? Okay, so I'm going to let you leave a little bit early. I see it's 11:30. I don't see that Melissa's here. I hope she's okay, because she's really very, very conscientious about being here on time. I'm going to end the meeting for everybody and wish everybody a nice weekend. Don't forget.
Thank you. Bye, Professor.
Don't forget to look for that quiz on Delta Math. Again, you have until next Friday to complete it, but I wouldn't leave it till next Friday. Okay, have a nice weekend. Bye-bye.